Hello everyone, welcome back to my YouTube channel. I hope you all are doing good. In our today's video, we shall study a simple activity on electrical resistance of a conductor. So for that, what are the items you require is nichrome wire, a torch bulb and a 10-watt bulb and ammeter and a plug key and some connecting wires. So all are simple items and you have to set up the circuit by connecting 4 dry cells. Each cell should be of 1.5 volt each and it should be connected in series with the ammeter, and XY is the gap between the circuit. So between that gap you have to connect the nichrome wire or 10-watt bulb or torch bulb. So you have to leave that space and you have to connect the other items, that is dry cell, ammeter, plug key with the help of the connecting wires. So the gap between X and Y should be left as such to connect the nichrome wire, 10-watt bulb or the torch bulb. So first what you have to do is you have to connect the nichrome wire between the gap X and Y, and you have to switch on the key or plug the key. So when you plug the key, the current will flow through the circuit and you note down the reading in the ammeter, how much the current is flowing when you connect the nichrome wire. Next, take out the key from the plug. Next step is replace nichrome wire with the torch bulb and again plug the key and note down the reading in the ammeter. And in the third case, you repeat the experiment with the 10-watt bulb. Here we have taken only 3 items, that is nichrome wire, 10-watt bulb and the torch bulb. You can take any conductors and you can connect between the gap and note down the reading. So after you note down or record the readings, observe the current in each case. Does it vary or the current is same in all the cases? See, what do you indicate from this experiment, and you must analyze. See, in this experiment, if you or in this activity, if you observe, the current is different for different components. Why the current vary? Why it is not same? Because the different conductors allow different flow of electric current. All the components will not allow same current to flow through because all are different. See, some components allow the current to flow easily. Some component resist the flow. That means the current may flow slowly. So in each case the current is different because each component is different and allow the current to flow differently. And we know that the motion of electrons in the electric circuit constitute the electric current. When there is motion of electrons, when there is movement of electrons in the circuit, then only the current will be flowing through the circuit. But the electrons are not completely free to move within the conductor. It also has some restriction. The components resist the electrons to move freely. They are restrained or resisted by the attraction of atoms. You know that all the components are made up of atoms. You have studied in chemistry. So it is restrained by the attraction of atoms among which they move. Therefore, the motion of electrons through a conductor is retarded by its resistance. So among the conductors, the flow of electrons is retarded or stopped by the resistance. And a component which has low resistance is called good conductor. Good conductor means it allows easy flow of current through the conductors. So it has low resistance. And a conductor having some good or appreciable amount of resistance is called a resistor. And a component which has high resistance are called poor conductors or bad conductors of electricity, and the bad conductors of electricity are called as insulators. Insulators, they not allow the good flow of electric current through them. Therefore, the good conductors have low resistance and poor conductors have high resistance. Poor conductors are nothing but insulators. So from this activity, what we observe is different components show different electrical resistance. They will not have the same resistance. So if you have any doubts, you can comment in the comment section. If you find this video useful, please share this among your family and friends. Thank you.